Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
We'll be looking at virtual work for this particular problem. We want to determine the equilibrium position as well as the stability, okay, of the position. We are given this potential function x cubed minus 2x squared minus 10 joule. Now, to determine the equilibrium position, what we'll do is to take the first derivative of the function and set it to 0, then solve the resulting equation to determine the positions. Okay, and for the stability, we will take the second derivative of the function and solve the plug in our equilibrium positions to determine stability. Okay, so that for the equilibrium position, okay, for the equilibrium position, we now have dv. Sorry, dv. The x is in meters, going to give us equal to, we set it to 0, so that we now have this will give us 24x 24 24x squared minus 4x, okay, equal to 0, as we said. Now if you solve this quadratic function, you are going to have when positive to arrive at when positive, x is going to give you equal to 0.17 meters. Okay, then when negative, x is going to give you equal to 0. So we can just plug in. So these are the positions, all right, equilibrium position. So for stability, you can take the second derivative. To do that, you're going to have the squared v, the x squared is going to give us equal to 48 x 48x minus 4. Okay, now if we use x being equal to 0.17 meters, 17 meter, okay, into the second derivative, that equation there, what we have here. So we are going to arrive at the squared this to be equal to um okay 8.16 and you can see that 8.16 is clearly greater than 0. So that tells you that for this, the equilibrium is a stable one, stable. Then we can also take when x is equal to 0. Let's look at this, what it will give us. Second derivative will give us equal to minus 4. And you can see that this is clearly less than 0. So for this, so at 0.17 position 0.17 meter, the equilibrium is stable, and at position 0, the equilibrium is unstable. So these are the equilibrium positions and their stability.